I'm a senior associate at Lysis U Bellotti and an associate professor at California College of the Arts. In this series of tutorials, I'm going to be presenting a quick start method for getting started with daylight simulations using Honeybee and Ladybug, which are plugins to Grasshopper and Rhino. These series of plugins are going to help us to access the underlying simulation engine called Radiance. It's an open source, physically accurate piece of software that's based on the root physical principles of light, developed by Lawrence Berkeley National Labs, was originally written for Unix and is an incredibly complex series of command lines to access. What Honeybee and Ladybug has done is give us a graphical user interface for accessing many of these commands. And so it's a great kind of gateway drug to get started with daylight simulations. You can download the software here from Ladybug Tools at Food for Rhino. And you should make sure to install both Honeybee and Ladybug. In this series of tutorials, I'm going to be using the legacy plugins 0.066 and 0.063. Make sure to follow the installation instructions carefully. It can be a little tricky, but the instructions are excellent when you download the files that comes with the instructions. Also, I wanted to point out a few resources. One is at Ladybug Tools. They have some amazing resources here, including a series of video tutorials getting started. These are much more in depth than the ones that I'm going to be presenting in these YouTube tutorials. But the developer of the software, Mustafa, has these 7 parts of a workshop that he gave that he recorded and are posted on YouTube. You can find them here. And they're phenomenal. You can also find a really fantastic forum at discourse.ladybug.tools, where a lot of people have posted questions and answers, and there's an open dialogue about the software. And finally, I wanted to show you this repository for template files. It's also maintained by the developers, and this has templates for both daylighting as well as energy, thermal comfort, and a lot more. You can explore this on your own, but there are it's a fantastic resource. The series of tutorials I'm going to be giving today are based on or intended for my daylighting class at California College of the Arts, although it may be useful for others, which is why I'm sharing it on YouTube. The tutorials are going to walk you through a workflow based on this template that you see here. This template has about 33 different parts to it. They are going to take you through from the through the process, and you're going to, in the end up with a series of daylight simulations based on this Rhino model that I've distributed, and your individual designs for the top lighting and side lighting for the gallery and reading room. You can see on the right, there's a series of outputs that you're going to get to eventually. This is the goal. Here is a true color luminance image adapted to the human eye, a false color luminance image, and an illuminance isocontour map that is laid over the luminance image. And on the way there, we're going to go through how to set geometry and materials, opaque materials as well as transparent ones. We're going to look at different sky conditions and how to model those skies. We're going to look at electric lighting, and then how to set up the analysis using specific parameters and views, and finally running the simulations and post-processing them. So that's the basic workflow. Let's get started. And I'm going to start from the end, which is always a useful way of approaching almost anything, I think, in Grasshopper, but particularly Honeybee and Ladybug. I'm going to start with the Honeybee Run Daylight simulation. And you can see that this component has a series of inputs, a series of outputs, and if you double click on the component, you'll see that this is all written in code, which is fairly understandable. It's written in IronPython, which is a variation on Python, and you can actually go through this if you're vaguely familiar with it. That said, I don't expect anyone in this class to do that. The first object we're going to look at is the Honeybee object, and the easiest way to do that is to create a Honeybee surface, and we're going to simply plug that into the object and then define the surface. The surface can be any geometry. I'm going to create a geometry holder and plug that in, and I'm going to, right now I'm just going to pick one piece of geometry here, and I'm going to set that. So now that's defined as that piece of geometry. And actually I'm going to set this up the same way as I set up the model. So I'm going to set this geometry, and I'm going to give this a name. I'm going to just call this sidewalk, and I'm going to plug that in. And I can ignore the surface type and the EPBC. These are related to another set of tools for Honeybee that are energy simulations. I have a whole nother set of tutorials on those. If you're interested, you can go take a look at those. Just search YouTube for Honeybee Quick Start tutorials. The EP construction, we're not interested, that's Energy Plus, but we are interested in the rad material. And there's a few different ways you can generate lots and lots of different materials. Right now, just to get started, I want to use the library of materials that are already in here in the software. And so I'm going to call from the Radiance library, and you can see that there are a whole bunch of material names already loaded in, but we can't see much more about that. To know more about each of those materials, we need a component called Radiance Materials info there. I'm going to plug this in, and you'll see that each material has a definition. So this context material is a plastic material, and it's got an RGB value of 0.3, 0.3, 0.3, and that's a gray material. And you can keep going down. You can see this is 0.2 RGB, 0.8 RGB, 0.5 RGB, etc. And these are all plastics. Then we get down to a glass material, which is an exterior window, and you can see the RGB values for that. These are now transmittance rather than reflectance values. And I'll show you a little bit more about defining your own materials. For now, let's just plug this. Actually, we need to select one of these names. So we need a selector. There's an item selector that comes with Honeybee. There you go. And we can plug a material in and then plug that into the rad material. So now we've got one material defined for our geometry, and each piece of geometry needs its own material. I'm going to go ahead and erase these now. So we've got one object. We need an analysis recipe. All of the recipes are located in this drop-down menu, and later in the semester we'll get to grid-based and annual simulations. Right now we're going to look at an image-based simulation. I'm going to drop that down on the canvas. I'm going to plug in my analysis recipe here. And now I've got a few things to include in the analysis recipe, including a sky file and etc. And views that go into it. For the sky, I want to generate a model of a sky that is realistic for our climate. And to do that, I need to find a component for the sky. There's a few different ways of doing this. We're going to generate a climate-based sky, and we're going to eventually come up with a sky file path that's going to go in there. And we have to tell it where the north is, and I actually need to turn north on here so you can see. So here's my north arrow over here, and Honeybee actually ships with a north arrow right there. And this is handy. I like to use this because it helps me to keep track of where north is in the Grasshopper file as opposed to my the north that I've got in my Rhino file. So for this, I need a number or a vector. I'm going to assign it 355, and the center point I'm going to have as a point that I'm going to define right there. It's 335. There. It's our 25 degrees. Okay, so we've got a north arrow. We need a weather file. I think for this we just need a weather file path. So I'm going to give it a file path, and I'm going to set one file path. I guess we'll use San Francisco. And we need to generate a month, day, and hour. For now, let's just pick a day. So September 21, 2 p.m. There. I'll show you a more advanced way of picking the sky in class, and it's in the template file, but we'll use this for this tutorial. So now we need the Rhino Views that we're going to use for the rendering, and right now we've got this on perspective view. Let's just keep this for now. The view is going to use whatever you've got in your viewport. So if you've got this zoomed in, then if it's like this, it will render this scene. If it's like this, it will render this scene. So what I like to do is to set a certain number of views in advance, so I know where I want my viewports to be consistent, and then before I render, I click on the view, and I'll go into some of these different views later. So back in Grasshopper, the view that we want is called perspective. So I'm going to just type in that view and hook that up. The camera type is, if you hover over, you can see there's a choice of perspective, fisheye, or parallel projection. We're going to go with perspective first. And this just turned red because you need to enter a number, not a word there. So 0 is perspective. A section plane, we can define a clipping plane, which I'll show you later. It doesn't have to be in section. It could also be in plan. Simulation type, if you hover over, you can see 0 is illuminance, 1 is radiation, 2 is luminance. The default is luminance is what I would like you to do for next week. So just to keep us honest here, I'm going to type in 2, which is also the default. And then image width and height. Why don't we set this for 1200 pixels width, and it'll automatically set the height based on your viewport. And then finally, the radiance parameters, or rad parameters. And the easiest way is to type in rad parameters. There we go, pops up. And we're going to go into a lot more detail on the rad parameters in class, but I want to give you a little bit of an overview here. If you hover over quality, you can select either low, medium, or high, which has some default parameters in there for you. And just so you can see what those parameters are, I guess you plug in the Readme, and it will tell you what these values are set at. Each one of these 21 different parameters control different render settings, which we'll go into more during class, as I said. and also there's in the assignment, there's a listing for it. Now, you can override any one of these settings by clicking here, and these A, B, AD, AS, AR, and AA are ones that are often overridden because they are very computationally expensive. They are the ambient parameters, that's what the A stands for, and I'm not going to go into them now, but AB, for instance, is ambient bounces. So right now, AB is set to 2, which means the photon will die after 2 bounces. But if I set this to 0, you can see that AB changes to 0. And that means that there's only direct sun is going to illuminate the scene, no bounces. There's also a place for additional input values, and you'll see in the reference file, in the template file, I've included a whole bunch of high quality settings here that you can use and plug into those additional input parameters. Okay, so let's take this off and have the low quality settings for now. I should caution you here that if you go with the high quality settings, this can take, if you have a complex scene, up to say 14 hours or so. So be careful with these settings and plan ahead. The best thing, what I usually do when I want to do a high quality render is to set it all up before I go to sleep. And then I get to wake up in the morning and be really excited. So, so there's all of our analysis recipe. That was a lot, but it's actually most of what we're going to be working on. So there's the analysis recipe, and here is the render geometry and material. These next two is to write the Radiance file and to run it. So I'm going to hook up a Boolean toggle to both of those. I'm going to set it to false first, and you'll see when I hit it true, it will run the simulation. And the next one is the number of CPUs that your computer has. You can just look this up and input it here. I know I have 4. The easiest way to check this is to press Control-Alt-Delete in Windows, and you'll get something that looks like this. If you go to Performance and open the Resource Manager, this will give you the number of CPUs that you have. So I have 0, 1, 2, and 3 is 4 CPUs. Working directory, this is going to be any local directory. It can't have spaces in the file name. So what I like to do is to use my Ladybug directory, which is on my hard drive here. It's automatically made by Honeybee and Ladybug, and I can simply add a folder to this, but again, no spaces. So what I tend to do is put the date with an underscore, and then that's my file path. So I'm going to highlight it, press Control-C, and then here press Control-V, and that's my working directory. For the rad file name, I can name this anything, but I'm going to just name it test01. And then for mesh settings, I usually have this use the defaults. If you have very, very high mesh geometry, like for instance, some of these sculptures might be, but might require slightly higher mesh settings, then you might want to set those higher. One thing is if you're getting holes in your model, you'll see this, but we can come to this bridge whenever we come to it. So export air walls, I'm going to ignore additional rad files. We will get to that in a second. And then again, overwrite results toggle here to not overwrite my results, and then it makes another folder with images. Okay, we are finally set up and ready to roll to render our one little entry porch right here. So I'm going to make sure that this perspective is selected, make sure that this is on perspective right here, and I'm going to hit go. And you should see some windows pop up. This is happening in my left-hand screen, so you can't see it in this one. And in the next tutorial, I'll show you how to view the results and start to post-process them.